I tend to just always draw it the same way, regardless, even if it might be an obtuse triangle or acute right triangle, could be anything. And then we'll label it. We have x equals 15. It's like that's a fat pen. Why is that? It's weird. Y equals 28. And x is 20.5. All right, so how do I know I have to use law of sine? I mean, I know that's all you know how to do yet, but
You're given a side and an angle.
you're given a side and the opposite angle. You have a pair, they go together, right? And in this case,
One angle.
yeah, you're only given one angle. That's exactly right. Okay, so in this is what we would consider an angle side triangle. You're thinking in my videos, angle side. I always do that annoying side. But when you're on the test, you'll think, oh gosh, this is meant to make sure to keep it sound. And that means we need to check for two triangles. So anytime you're given angle side, that's when you know to check that you might have two possible triangles. Okay. So when I set this up, 15 over sine of 20.5 is equal to, and I don't really have any other option, right? I have to use y and then the sine of y. And so I'm going to cross multiply. And what do we get for y? Let's see. Right here. Did you get y is equal to 40.823?
I got 4.
I got 2, 3. Yeah, I got
What
2,
did
3.
you do?
I got 2, 3.
I don't know. I did sine of 20.5.
Okay, times 28,
Oh, sorry, 28
divide by 15.
divided by 15.
Okay, and then did you round or anything yet? Don't round yet.
Yeah, I did. And then,
So you should have 0.6537 something.
and this one, yeah, 0.53720.
Mhm. And then do second sign, second answer.
Oh, there it is.
Okay, so once I do that, then I'm free to do anything else with my other side. So I could do 15 over is equal to, what do I want next? V, I guess, is IV, right? Okay, so how do I know what angle Z is?
180.
Yeah, so what do we get? 180 minus 40.823 minus what we were given, 20.5. All right. Okay. So what do we get for? So did you get side Z is 37.58? 570?
Yep.
Okay, so is that the only possible triangle I can have? Okay, so how am I going to figure that out? How do I know
Because if you pretend, and at least in this scenario, y is equal to e, x is equal to a, and scenarios where b is greater than a, we can do three triangles.
that? Right, that's exactly right. Okay, that's one way to do it. What's another way?
Wait, so 180 minus 40 and then 1.5.
Right, that's another way to do it too.
Well, also
Okay.
we just use our chart.
You can use your chart. So if when you're doing these, if we had done, let's say when we first started, so this is our first triangle, that works, right? So if we do this again though, and when we first did this, we said you have to put the x's together, right? 15 over sine of 20.5, right? And when I do the, I get my answer for y, you're gonna get your 40.823, but we could also get, because if you, so when we,
Wait, how much money got the 37?
My question is, so it's just the side, the smallest side also has an angle that is smaller than the angle that corresponds to the other side. That's how you know. So like my question is like, how do you know like which side is X, which side is Y? Like you can choose any side you want. So like that's why the whole A B thing doesn't work for me, like in my head.
well, you know that the sides have to be, you have to label your sides across from your angle, right? So if you wanted to change the names of this to fit, you know, if it helps your brain work that way, you could just, like if you wanted to change this to side A and that to A, and this to.
So my thing is like you can make A the angle where it is now, or you could like swap A to C or B A.
Because like in the homework,
But they're still opposite.
gives
Yeah.
you C in the homework and no B. So then is it the first one? Like how do you know which is greater than?
That's the
Okay, so if you're using, you're saying if you're using
like,
your.
I'm thinking like different like terminologies, like the
Because-
smallest side, it also has an angle that's smaller than the other angle of the smallest of the larger side. then
Wait,
it
say
has-
that again. You lost me, but you lost me on a question.
If the smallest side also has an angle that is smaller than the angle that corresponds with the larger side, it
Mhm.
has two. That's the only way.
Okay, well, that's the same thing as if you set up your triangle to have, like if you're looking at the A greater than B or A less than B.
Yeah,
Does that make
So how do we
sense?
know which one's A and which one's B?
that's why I use my. so like, on the record sheet that is one that has the angle degree and the-
Yeah. This has to be A, that's exactly right, and then it doesn't matter if you put B down here or B over here, it doesn't matter. Usually in the picture, B is always up here, but we could have written the 28 over here instead of here.
Right.
But you can also make a triangle if I subtract 180 minus 40 right here. 180 minus 40.823. That gives me an angle of 139.177.
And we have two angles.
You with me? That's how I do it. I don't even look at the
That's
angle
two
A.
angles.
So if you can take the angle that you found, Y here, and I subtract that from 180, so 180 minus
40, right, yeah. So you like 140 roughly.
and I get 139.177. And I say, okay, well, could that make a triangle with the other angle I was already given? So what I do then is I go back and I add that to the angle I was already given. So if you were given a little angle, there's a likelihood that you're gonna get two triangles, right? So if you add that back in to 20.5, and it's still less than 180, there's still room for one more angle to fit into your triangle to add up to 180. Does that make sense? So once I add those together at 159.677, now I subtract that.
We have subtracted 118 from 180.
No,
I know what to assign.
sorry, that is E2. I'm talking too much. This is my Y.
Yeah, but okay, so 20.5, that is X on both triangles, right?
Mm-hmm.
Okay, so what is our one?
So, okay, 20.5 angle X can't change. You're given that.
Right.
Side X can't change. You're given that.
Okay.
Side Y only thing that can change is these two angles, right? Y and Z
That's not,
and side Z.
is that angle Y now or that angle T or does it matter?
That's the new.
Yeah, it's a new angle Y. Whatever you solve for,
Mhm.
okay, in this case, we solve for angle Y. I probably confuse things by calling everything A, B, C. So let me erase that.
Because we were given Y to find that history angle in number 1.
Yes,
That's
that's
the
gonna be
same
your
thing.
second angle. Exactly,
That's
that's
our
exactly right. Because I have to, I need a pair, right? So I have to solve for angle Y. Got that?
No.
Because I have my pair here, my blue make a pair and the red make a pair. So whatever I'm solving for angle Y, when I solve for that angle and I subtract that angle that we got, 40.823, subtract that from 180,
Mhm.
that gives me my second
That gives you
possible Y.
139.
That's the
That's
139.177.
Y2.
Yep.
Okay.
Okay, so that's my second one. And I still don't really know if that's gonna work yet or not. Does it make a second triangle or not? So then use that second Y and say, okay, well, can that make another triangle? So
That
this
are given.
plus the angle I was given, 20.5, is that, when you add this together, is it less than 180? If yes, then it makes another triangle.
So even if it adds up to 179, we're gonna have a 1 degree thing.
Yeah,
All right.
okay?
That's cool.
So law of cosines is basically still setting up a relationship between the sides and the angles that you have in your triangle. These are all the same formula, just manipulated differently, pretty much, right? So if you have two sides and an angle, you can solve for your third side. That's what the ones on the left are showing you, how to solve for your third side. If you're given 3 sides and no angle, you're going to use the one over here. Okay? So
That's
these
the
would be,
finding thing.
say it again?
The ones on the right are fine, like any angle.
You're finding any angle in your triangle. Yeah. Okay? So when you're doing it, and again, you'll have your notes and all that, but so when you're solving an oblique triangle is just anything that's not a right triangle. Remember, we use the law of sides if we had angle, side, angle, and angle, angle, side. And then there's only one triangle. It's super straightforward. That was like what we did the day before the break, right? Everything worked out nicely. You're thinking easy peasy, lemon squeezy, rock the races, everything's good. But when you have 2 sides and one opposite angle, angle, side, side, that's when you're going to have the 2 possible triangles like we just did. All right. So, but if you have any other situation where you have side, angle, side, or side, 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 then you don't have the relationships you need to be able to use law of sine, right? So you have to use law of cosine. Okay, so there's kind of 2 tricks and they're a little bit opposite. So you're going to just kind of keep them straight. But if you're given 3 sides of the triangle, you always want to solve for the largest angle first. Okay? Because what that does is that's going to give you you already have your 3 sides, so you only have one triangle possible. Okay? So you want to solve for the largest angle first because that could be an obtuse angle given a side. Does that make sense? You want to solve for the largest angle first, and then you can use law of sines to figure out the rest of your triangle. Okay. Of course, we need to be in degree mode. Yeah. Okay. So we'll do one of these. Okay. So I left them all in A, B, C, so we can use the formula. Okay. So in this case, I have 3 sides, right? So what angle do I want to find first?
B.
Angle B. All right. So I'm going to get that one first. So I'm going to set it up using cosine of B. And then it looks really complicated, but if you think about, okay, I'm looking for angle B. If you look at your formula here, all right, see how it says A squared plus C squared and then minus B squared? So just take the letters that don't go with the angle. A squared plus C squared and then subtract the side that does go with that angle. All right, and then 2 times the ones that don't go with the angle. Okay, so it sounds complicated. You guys don't really have to memorize it because you have your notes. Normally you would have to memorize this, but, and then you just plug things in. So I'm going to get cosine of B. And then if it helps, go ahead and label your side. So I have 8 squared plus 14 squared. And so I get negative. Right? So don't round yet. Now in my calculator, I'm just going to do second cosine second answer to pull up the angle measure. Angle B, so what do I do now? Okay. So if I do angle A, what would that be? And we found B, so that's 19 over sine, and I can still keep that in my calculator so I don't mess things up. But this is why it's really important to round to 3 decimal places. So I can say sine of my second answer, sine second answer. And then times 8. Divide by 19. For angle A, I'm going to do inverse sine now, and then here. Something like that. Is that what you got? 22.075. All right, so how am I going to get angle C?
185.
There you go.
So how do we know if we're gonna have more than one triangle for this?
You won't. You'll only have one. But that's why you want to make sure and find the longest, do the longest side first so that you don't get some kind of erroneous info.
Alright. So basically,
Okay.
these are the money, these are the go-to. And you only got one triangle,
Yeah.
these are the knockouts.
And now you could use law of cosine to solve the whole thing, but it is much, I think it's easier to do law of sine. Okay. All right, so let's look at why. We can do one more or 2 more if you want to. Okay, when you're given side angle side, now the trick is that you want to solve for the smallest angle after you find the missing side. You have to find the side first, then you're going to use the smallest angle. And it'll make sense when we do this one. Okay, so we have side angle side, right? So the first thing I have to do, I can't use that law of sines here because I don't have any kind of pair, right? I only have one angle. I don't have any opposite side and opposite angle combination. So in this case, what am I solving for? B, yeah. This is C, right? And that's A. All right, so now you're going to use the formulas that are on the left side of your paper, right? So I'm going to solve for my side B. And if you look at your formula here, it kind of is the same logic. Like if you're solving for B, you see how these are the sides that don't go with B, right? And then minus 2AC. So that's the formula I'm using. So I'm going to go ahead and plug stuff in. So B squared is equal to 10 squared. Okay, so this is where you want to be careful and you want to multiply all that stuff together and make sure it's all subtracted, right? So you can do it all in your calculator, or you can do this part first and then go back and do 10 squared plus 15 squared minus whatever that answer was. just make sure that you're subtracting all that together. So, all right, let's try it. 10 squared plus 15 squared minus parentheses 2 times 10 times 15 times cosine 30 plus you.
Plus your.
All right, but I need b, so you have to take square root, right?
They got square root.
Mm-hmm. Okay, so now I have side B. Now what angle do I want to find next? 10 over sine A, and then I have my B. Over sine 30. All right, do we get A is 38.263 degrees. And then when I get C, I'm just going to do 180 minus 30 minus 38.263, and I get actually this triangle. You can see what I'm talking about what would happen if you got the wrong angle first in this triangle, actually.
Low-key.
Okay, look, try it, see what would have happened if we had gone to use 15 and sine of C. Try that, see what happened. You would have gotten a BB. Right, so that's C. All right, you see what? I just want you to try it. If you had used the longest side, you would have had. Okay, so we would have had 8.074. Sine of 30 is equal to 15 over sine C. Try that and see what happens. You'll see what I'm saying. You're going to get a mistake here. If I do that, you see how C, I would get that for C. Y'all see that? That's kind of important. JC, you see why you can't do that?
Yeah.
Okay, so if I had gotten that for C, that does not work with the other sides that I was given. Okay? Because if you have 180 minus 68.265 minus 30, you're going to think that you have, you're going to think you get different angles here for your triangle, but it doesn't work with the sides you were given. Does that make sense? Because you're given these constraints of 15 and 10. Once you find B here, you have to use your do the next smallest side, or you're going to get the wrong answer for C. If C is going to be an obtuse angle, it's going to give you the wrong one. Okay. If you look at the next example, which I won't do, but the next example, that won't happen because you're given an obtuse angle. So you can't have two different obtuse angles. There's only one possible in any triangle, right? So you couldn't, it wouldn't really matter in this situation. But on this situation, when you're given an acute angle as one of your, as the only angle in your triangle, that's when you need to make sure and solve for your side using law of cosines, and then use the side opposite, the smallest side to do your solution. Right? Okay, so it looks like a lot of work, but it's really pretty straightforward. It's not so bad.